For perfect problem 5 for Math 112, you're given this triangle here and told some side lengths. B equals 4 root 2. A equals 8 root 3 over 3. Okay. And angle measure A is 45 degrees. So even if it doesn't look like it, maybe it looks like it, I can't tell. That right there is 45 degrees. And you're told to determine all angles and side lengths. And it gives you a hint on doing that. It says follow these steps below. All right. Create a right triangle by connecting vertex C up here with a point on side C. In other words, draw this line right here. Now you got a right triangle. Call this segment H. Okay. Calculate length H. Okay, the way I can calculate length H is I need a trig function that relates together this side and this side. And so since this is the only angle I know, I need a trig function that relates together the side opposite this angle and the hypotenuse. And the one that does that is the sine function. So the sine of 45 degrees must be equal to this thing I don't know, h, divided by 4 square root of 2. And because I happen to know the sine of 45 degrees, because I have my unit circle memorized, I get that root 2 over 2 equals h divided by 4 root 2. So to solve this equation for h, I can multiply both sides by 4 root 2 and get that h is equal to 4 square root of 2 times the square root of 2 divided by 2. And that all just simplifies to 4 because square root of 2 times square root of 2 is just 2. And that 2 and this 2 cancel, you're left with just 4. Okay, so h is equal to 4. One of the many steps done. I think that's part A. Part B says determine angle B using a trig function in sides A and H. Okay, maybe in another color here. Got to figure out what this angle is. But I know, again, I'm going to use the sine function, that the sine of whatever angle this is, sine of B, is equal to the ratio of the length opposite, so 4 in this case, divided by the hypotenuse, which is now 8 root 3 over 3. Kind of ugly looking, but maybe I can simplify it a little bit. I can think this is really 4 over 1 times 3 over 8 root 3. So I guess you could call that 12 divided by 8 root 3. And you could leave your answer like this, but what I'm going to do is show you a benefit of rationalizing the denominator. If you multiply the top and the bottom by the square root of 3, you'll get 12 root 3 divided by 8 times 3. Which is 12 root 3 over 24, which is the square root of 3 over 2. Wait a minute, so you're telling me that the sine of B is equal to the square root of 3 over 2? And you're asking me to figure out what B is? I can do that from my unit circle. I know that the angle, whose sine is square root of 3 over 2, is pi over 3, aka 60 degrees. The sine of a 60 degree angle is root 3 over 2. So B must be 60 degrees here. Determine angle B using a trig function. I think I did that. Determine angle C. All right, the nice thing about angle C here is the sum of the interior angles of a triangle, I'm back to my big triangle here, must sum to 180. So 60 and 45 is 105. So I would need 75 more to make 180. Determine side C however the hell you want. Okay. A few options on how you can determine side C. I think what I'm going to do is use the Pythagorean theorem twice, maybe. Is that the easiest way? Well, I don't know. Maybe, maybe not. Okay, actually, I don't know that I'm going to do that. So what I'm going to do is note if this is a 45 degree angle, then this length is the exact same as this length. Right? This must be 4 right here as well. If you don't believe me, the tangent of a 45 degree angle is just 1. And opposite over adjacent, in order to make this 1, this better be a 4 right here. Determine this length here. Well, let's see. Maybe I'll use the fact that the cosine of a 60 degree, maybe I should be writing this down. The cosine, how about I'll write the step I just did. Tangent of 45 degrees would be equal to opposite 4 over, I need another letter here, maybe I'll call this D. 4 over D. And the tangent of a 45-degree angle is just 1. So 1 is equal to 4 over d. So d is equal to 4. Unfortunately, that doesn't tell me length c here. It tells me kind of a portion of it. But I can figure it out if I can figure out length e. And to figure out length e, I'm going to take advantage of the fact that the cosine of this 60-degree angle right here gives me the length of the adjacent side divided by the hypotenuse. So e over h. And from my unit circle, I know the cosine of 60 degrees is 1/2. And I know h. Wait, I messed that up, didn't I? Damn. Okay, so the cosine of a 60-degree angle is adjacent over hypotenuse, so it's e over a in this case. A was given to me as 8 root 3 over 3. But I know that a cosine of a 60-degree angle is just 1/2. So 1/2 equals e divided by this mess, 8 root 3 divided by 3. But I could solve for e if I multiplied both sides of the equation by 8 root 3 over 3, in which case I would get that 8 root 3 over 3 times 1/2 is what e is. And that simplifies to 4 root 3 over 2. No, sorry, 4 root 3 over 3. Reduce 8/6 to 4/3. And you get that e is 4 root 3 over 3. Is that what I said? Yeah. And therefore, length c is 4 plus 4 root 3 divided by 3. It's that entire length. There's step 1. Unfortunately, there's still a step 2. And I don't have a whole lot of room for it, but I'll figure it out. Maybe I should number these a little bit. This was A. 1A. This was 1B. And this is 1D. As was this. And now I'm moving on to part 2. Maybe up here. And 2 says, now go back and find a completely different answer. Wait, what? Different answer? And what it tells you is, you first find h. Okay, I still got that. But then when I'm calculating angle B here, it turns out there's another possibility. How could there be another possibility? Well, down here, sine of B equals the square root of 3 over 2. That does not mean that B is equal to 60 degrees. So B could be. So could be B. So B, possibly, sure. I don't know if this is making sense. B could be 60 degrees, but B could also be 120 degrees. B could also be 120 degrees. Because the sine of a 120 degree angle, 120 degrees is 4 pi over 3. And the sine of 4 pi over 3 is the same. No, that's not true. It's 2 pi over 3. 120 degrees is 2 pi over 3, and the sine of 2 pi over 3 is the same as pi over 3, which is root 3 over 2. So B could also be 120 degrees. If B were 120 degrees, that's going to change the rest of my answers. So now, if this is 120 degrees and this is 45 degrees, that's 165 degrees. So now C is just equal to 15 degrees. And now when I'm trying to figure out little c, well, a lot of the work will be the same. This is still 4, but now what my triangle will look like, maybe I need to draw the picture, is I start out with this 45 degree angle. Maybe I should have made that a little bit bigger. This right here is 45 degrees, and this is A. But now this is 120 degrees. And I can still create right triangles. I can still do all that same math that I did before. But now what you'll see is my right triangle is hanging out here. and that, well, this length is still 4, this length right here is still 4 root 3 over 3. No, sorry. This length right here is 4 root 3 over 3. So what that tells me is that this length that I'm looking at, so C is equal to 4 minus 4 root 3 over 3. So the things that change are angle C is now just 15 degrees, and side C is 4 minus 4 root 3 over 3. Everything else stays the same. And I guess that ends this problem, so I'll stop this video here.